Hello? Okay, let's get started. My name is Tess. I'm a developer, and we're going to talk about debugging beyond step-by-step debugging. So we're going to talk about beyond step-by-step debugging in Visual Studio and .NET debugging in general. So much beyond that we're not actually going to do any step-by-step debugging at all. So some of you might know me from my previous role as a support engineer, where I would troubleshoot other people's crashes, memory leaks, and performance issues, essentially anything that you couldn't step-by-step debug. And this is sort of the agenda for today. We're going to take a look at what you do when you can't step-by-step debug and kind of strategies for troubleshooting these kind of issues. So if you can't step-by-step debug, then you have to resort to something else. And that something else is sometimes profiling. We'll look at that. But sometimes it's also memory dumps. How many of you have used memory dumps before to debug things? Wow, awesome crowd. So we're going to talk about memory dumps. And those of you who have worked with memory dumps know that a memory dump is essentially a snapshot of a process and all the memory that it addresses. There's also kernel mode dumps that are snapshots of the entire system. We're not going to deal with that here because we're just looking at one particular .NET process when we're debugging something. But looking at a memory dump is a little bit like looking at a crime scene. So you take a picture and you can't move forward because it's not a video. You can't move backwards because it's also not a video. But you can find a whole lot of clues about who did the crime. And that's what I'm really, really interested in when it comes, and that's what intrigues me about debugging, that it's so easy with memory dumps and such to actually figure out who the culprit is. So let's take a look at what this looks like. And we're going to start off in one of my favorite tools. This is Windbg. You probably have this on your machine even if you never thought you installed it, because it comes with the debugging tools for Windows. It comes with a Windows drivers kit. It comes with a Windows development kit. Essentially, you install Windows anything and you'll get Windbg. And lately, I've been doing a lot of UX, and one of the things I'm usually talk about is UI should be super understandable, which, yeah, this is not. In fact, I don't know if I have internet, but this is kind of what it feels like to start Windbg. So to make it just that little bit more understandable, I'm going to go ahead and copy some commands, because in Windbg we use commands. So we'll get to Visual Studio later, don't worry, but we just kind of need to figure out what it is we're looking at. So I copied a few commands into something called a scratch pad, because when you debug in Windbg, you might want to write down things like the evidence that you're looking at, or your Twitter handle if you're presenting something. And then we have the actual memory dump. And the memory dump that we're looking at here is a memory dump taken off a process. This is a WPF process called the precedent. It had an unhandled exception with this funky number. We'll get back to that later. And then it doesn't tell us too much more, because it's expecting us to do some PowerShell-y goodness and write some commands. So one thing you get good at really quick in Windbg is learning really weird stuff, like learning really weird characters and stuff. So we'll start off with a command that looks like this. And I'm going to see if I can do this. Let's see. So up top, you're going to see a magnified version of what we're looking at the bottom. Well, that didn't work very well, so we'll skip that. Can you see what's at the bottom of the screen here? Yeah, okay. So our first command is going to be tilde, which is Klingon for threads. And we're going to look at all the threads, and we're going to run the command K. And the command K is stack. When you're a debugger, you don't like to write a lot of stuff. So we're going to look at mostly one letter commands and very short commands. K is stack. It should have been S, but S was already taken for set. So this is one of the 28 commands that you can run in Visual Studio. Tilde star K. And what you'll get then is a list of stacks. These should look fairly familiar to you if you're used to Visual Studio, because they're actually typically the type of stacks that you would look at. But one thing that might be a bit challenging to look at is the number of threads that are actually in a very, very simple WPF process that's been going on for just 2 or 3 seconds. So which ones of all these 22 threads are important? Experience will tell you which ones, but if you want a quick fix, then take a look at the healthy process and compare the threads and see if this was in a healthy process and this was in a sick process, then maybe that's not important. I'll just scroll up a bit and point out a few threads. So one of the more important threads is this finalizer thread. So there are a lot of supporting actors in this whole crime scene, and one of them is the finalizer thread, which essentially goes in and terminates everything, like Arnold Schwarzenegger. So what it actually does is it calls all your destructors. So if you have an object that has a destructor to get rid of any native items like a file handle or something, then that would go on this single thread, which means that if you block this, then you're screwed because you'll have a memory leak because nothing else can get finalized anymore. But this was not anything that was going on in this process because we're looking at a crash. And when you take a memory dump of a crash, what you'll have is like one active thread, and that active thread will be the one that is actually the culprit in this case. So that active thread will also be marked with a dot. Again, a one-character thing that explains everything. So thread 0 is the one that caused the problem. It was throwing some kind of exception. And then underneath here, there is a lot of weird stuff that we can't really decipher. This didn't look like any of the threads that we saw below that we could actually read out the function names and everything. And this is because this is a .NET thread. So this is a managed thread, and Windbg is not a managed debugger. Windbg only understands like C++ and other such things, so we'll have to have an interpreter. And that interpreter is called SOS. So we're going to load up SOS, and this command, what it does is it will load up sos.dll, an extension to help us translate, and it loads it up from the same directory where clr.dll is located, which, if we look, is going to be in the framework directory. So I'm just pointing this out because this means that if you have the framework on your machine, you also have SOS. And since you have Windbg and you have SOS, you're pretty much all set for this. Now we're going to run a few commands in SOS to give us some more information and to figure out which ones we're going to run bang help. So bang, in this case, is Microsoft short for exclamation point, because exclamation point is very long. So we'll run that and we can find out what you can do with SOS. Among other things, you can do things like run bang threads. And this will show you the managed threads, or the .NET threads in the process. So it will show you a few things like the finalizer again, recurring character, and then the fact that the first thread, thread 0 here, was hitting an argument out of range exception. So with this information, kind of know what we're looking for, but we would like to look at the stack just like it looks in Visual Studio. So we're going to run another command called clr stack, and that's going to give us a stack that is very, very familiar to us if we know Visual Studio. So we have some next button on click that calls into go to another function, and that in turn goes in and throws an argument out of range. At this point, we could just look at the code and figure out what's going on here. And we're kind of done in Windbg so to speak. But I just want to show a few more commands that we can run here. One of them being dump stack objects, or again, since debuggers are lazy, DSO. And this will show us pretty much the same thing that you would see in Visual Studio if you were looking at the locals window. So we can see our argument out of range exception. In fact, we can see it 7 different times. Anyone know why? It wasn't because it was thrown 7 different times. It's in fact the exact same system argument out of range exception. They all have the same address. But Windbg doesn't do the fancy stuff about putting, like figuring out that this was already shown once before. It's showing up multiple frames, and therefore it's showing up multiple times here. So that's the thing. So I'm going to click on this, and what this will do is it will dump out the argument out of range exception, and now I can go in and do things that I would normally do in Visual Studio, like look at the message, for example, find out the index was out of range, yada yada, and that gives us just a little bit more information about what's going on. So that is all stuff that you could do in Visual Studio, and that's kind of not all that exciting. What is very exciting, though, is that something you probably haven't done in Visual Studio is looked at all the objects that your process can access, or that your process has created. So I'm going to run a command called heap-gc, and with .NET, so if you run a C++ app, then what you do is you do a new, and you get some random piece of memory from the operating system, and then you do another new, and you get another random piece of memory from the operating system. But there's no central location where you can actually find out all of these pieces of memory. So you have to keep track of them, and you have to delete them, and all that stuff. And that's why we use .NET, because .NET has memory management as a service through the garbage collector. So the garbage collector keeps track of everything that you allocate, and it keeps track of it in segments. In this case, we can even know that we have allocated this much, 7 megs of .NET objects. And if we look at these heaps, now we're getting kind of deep into the internals of .NET, but it's kind of important to figure out how we can actually get here. So dump heap, and I'm going to just dump out one of these segments. Well, that was an extraordinarily bad segment to dump out. Why? Oh, okay. If you dump out from one location to the same location, that will kind of not show you very much. So dump heap like that to here. And what we see here is how memory is laid out in .NET. So I think this is extremely interesting, because the fact that .NET lays out our objects one after another means that we can enumerate all the objects in a heap. So we can take a look and find out every single object that you have ever allocated, that is still not garbage collected. We can take a look at it, we can take a look at the data, and everything like that. And the magic happens not only in that it's laid out one after another, but it happens because if we go up and look at this argument out of range exception, .NET objects are sort of like self-explained. They have a method table that tells you what methods they have. They have an EE class that's kind of like the blueprint that says, at offset C, I'm going to have an exception method string, and at offset 1C, I'm going to have a help URL, and so on and so forth. So it tells you how the object looks, and it also tells you how much memory it uses. So what this means now is that we can go in and do this. We can go in and say dump heap stat, and we can find every single object in the heap. This is a little bit scary sometimes if you're storing like passwords or stuff in clear text and some variables, because if I create a dump of your process and I look at all the thread, or I look at all the strings, let me go ahead and do that. I'm going to go ahead and do dump heap dash type system dot string, and I'm going to say give me the ones over 500 bytes hexadecimal, and it's going to pop out like all the strings that match that criteria. And I can go in then and look at them and see, oh, this was what's in that string. Maybe that was your password. Just be aware of that, because the fact that I took a memory dump of this process doesn't necessarily mean that I have to own this process and own all the code for it and anything. I can do this in any process. I can also do some other things in here. I can figure out why this object is still around. So I'm going to do gc root, which will go through and figure out how come this object was not garbage collected. Well, it wasn't garbage collected because this string is a member variable in some section XML info. There's a member variable in some section input, and yada, 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 all the way up to some client configuration section and some that was pinned, and therefore it will not be garbage collected. Because if you tell it that I don't want this garbage collected, it won't be garbage collected. And finally, while we're here in the memory dump, let's go ahead and run a command called lm, which means list modules. Now we're getting up to 2-character command names. And this will list all the DLLs and all the EXEs, well, the one EXE, in your process. So you can go ahead and dump out things like the version of this. If you took a memory dump of maybe a process that was crashing at a customer's machine, and you want to figure out, did they have the hotfix, did they not? This is your place to do that. And this is also your place to go ahead and dump out the code for this and do some IL spy on it. So that is the magic of dumps. You can get to anything that's in the process, and because .NET works as it is, you can enumerate every single object in the process. So let's go back and have a look at where we are. So we can see the threads, call stack objects, modules, .NET heap, and that's all cool. But when you create, when you troubleshoot a memory issue or a crash or something like that, it's important to get the memory dump at the right time. So we'll take just a few minutes to look at how you collect a memory dump. So there are a couple of tools to do this. The simplest one, I would say, is just right-click in the task manager and choose create dump. Awesome if you want to take a memory dump of a process that's running now and you want it in the state that it is right now. If you're looking at a hang or if you're looking at a memory leak, that's awesome. One caveat to this, it has to be a 64-bit process because it's going to take a 64-bit memory dump. And it's awfully hard to troubleshoot a 64-bit dump of a 32-bit process. If you want to get a memory dump of a certain situation, like for example a crash, you have to go a little bit more specialized, and you can download something like procdump. Procdump is a tool that comes with sysinternals, and the cool thing about it is that you can download it on one machine, and then you can copy it over to another machine and just use it. So you don't have to install it on a different machine, which is often an issue, for example, on a server or whatever. And the other thing that's cool about it is that you can write a few command line parameters, and you can say, for example, just take a memory dump when it's crashing, that's -E, or -C for if CPU has been over a certain amount for a certain number, a certain time, or -H for if a window has been hung more than 5 seconds. And sometimes you want to go even a little bit deeper, then you can use a tool like debug. So debug, you can just download it from, well, search for debug. And what it has is rules that you can set up for all IIS processes, for example, and for specific situations like I want to get a memory dump every time I get a file not found exception. You can do that even though it's not crashing the process, you can get a memory dump of it. And then you would go in and analyze dumps, and we've seen Windbg, so you can of course do it there. And you can use debug to analyze the memory dumps as well. So if you do that, what you will get more than Windbg is debug is a tool that will run scripts for you. So when I worked in support, and one of the reasons I left support was because I felt like I had debugged any issue there was. Like, they all looked pretty much the same. And they all went through the same steps of looking at the stack, looking at the exceptions, yada, yada, yada. So we tried to automate this and put this in a tool so that you didn't have to remember like the Klingon word for threads. And what you do then is you run it through this tool. It will run all the commands, and it will create a report for you that nicely tells you exactly what's going on in 80% of the cases. And then in the other ones, you will have to use Windbg or something else. And you can also use Visual Studio. So we'll have a look at that because it's super, super neat to debug memory dumps in Visual Studio, actually. But we'll start off, we're going to look at crashes, performance issues, and memory. Sorry. We're going to look at crashes, performance issues, and memory leaks. So we'll start off with crashes. And a crash typically manifests itself like this. My mom calling in, Tess, that internet thingy, it's not working anymore. And I'm going like, okay, Edge? Mom, what did you do? I didn't do anything. Okay, so if she did not do anything, then who did? There are a couple of things that can cause a .NET crash. And we've already seen one, which is an unhandled exception. So exceptions go from first chance, where you still have a chance to handle them, to second chance, where you're screwed. And that's what we ended up with here. So that's one thing. But then there are some special exceptions that will only go to first chance. So stack overflows, out-of-memory exceptions, and execution engine exceptions. They will only go to first chance because once you have a Stack Overflow exception, how do you handle it? By putting an exception handler a little bit further up on that stack that you already overflowed? Not possible. So that's why that won't work. Out-of-memory exception, the same thing, the exact same thing. And the execution engine exception is usually a bug in the .NET framework somewhere. So in that case, the garbage collector is messed up and you can't do anything. And then you'll also often see, if you grab a memory dump when the process exits, that it might maybe not have been a crash necessarily. It could also be someone is killing or recycling the process, so that's a fairly common one too. And when you troubleshoot these issues, you just go through a couple of simple steps. So the first one is always check the event viewer. It will give you a lot of juicy information. And then capture a dump when the process is crashing. So reproduce the issue somehow and set up proc dump or set up debug diag to capture the dump when it's crashing. And then look at the one thread. Well, you can look at all of them if you want to, but yeah, you only have to look basically at the one thread that's triggering the dump, because that's going to be the one that's crashing. So we saw that already when we looked at Windbg. But we'll go ahead and try one out. So I have this precedence app. We've seen that before. And what's going to happen here is that I'll go to Mr. Clinton. And then I click next, next. Okay. Yeah. We all kind of knew that would happen. So what happened there? Let's go ahead and debug that for a second. So I'm going to go ahead and do proc dump -ma. This is mini dump with all options. It's actually a full dump, but we can still call it the mini dump with all options. So, and then we say we want to debug the precedence.exe, and we want to say -e because we're going to wait for an exception to happen. And now I have to start this process to have something to attach to, because this is going to attach It's going to not attach as much as, for example, Visual Studio is going to be low-level attaching, but it's now going to sit there and monitor, and whenever it exits, it's going to crash. It's going to create a memory dump. So let's do that again. Okay, that was pretty quick. So now, well, I've done this a couple of times, practicing, and we get a memory dump from this. So we already saw how to troubleshoot this in Windbg, so I thought I'll now go in and do the same thing, but in debug diag. So in debug diag, what you do is you choose one of the rules, and we know it crashed, so we're going to use a rule that's called a crash hang analysis. I apologize if you can't see this because it's too small, but it says crash hang analysis there. And then I'm going to go in and I'm going to pick the memory dump. Well, I can just pick this one. They're all the same. And I'm going to start the analysis. So now it's going through the exact same steps, looking at like all the stacks, looking at previous exceptions, yada yada, what was going on the thread that caused the issue. And it gives us this report that says, on thread 0, there was a CLR exception, it was a system argument out of range exception, and this was the issue. And if I go in and look, it will also give me the proper stack for what went on. In fact, if I go through this report, it will also give me some other things like, I don't know, the more about the exception. It's going to give me previous exception information and all that stuff. But at this point, we pretty much know what's going on just from clicking on that one crash hang analysis. Isn't that fantastic? A little bit, right? I did this. So that is if you don't want to get into Visual Studio. If you don't want to get into Windbg. But there is actually one more step we can take, and that's using Visual Studio and its debugging features. So I'm going to go ahead and do File, Open, File, and I'm going to pick that same memory dump. And it now gives me the option to do a few things. So let me see if I can actually get that magnifier working. Okay, so you see where I'm pointing, right? So now it tells us that, like we knew, that this was this weird exception. By the way, if you're really into ASCII tables, you could decipher this, and 434352 stands for CCR. That's COM callable wrapper. That's the .NET exception from 4.0 and forward. In 2.0, it was the ASCII characters for COM. So while everyone was saying we're going to get rid of COM and do this new thing called .NET, there were some infiltrators that were still kind of liking COM in the product teams, at least the ones that came up with the exception numbers. We're going to go ahead and do debug with managed only. We have a few options. Debug with mixed is if we also want to go in and look at native stuff. And it's then going to go in and troubleshoot the dump and show us what caused the exception and put it as the actual line of code that caused the exception. That is awesome. That is stuff that you get, though, if you have the code on your machine and you ran a debug version and stuff like that. You would still get things like the call stack and things in Visual Studio, and you would be in a familiar environment, but the code will take you exactly to the slot. So don't dismiss dump debugging and Visual Studio, and Windbg. Okay, that was crashes. Oh yeah, we should look at the event viewer, because I say always check the event viewer. And let's have a look at what that looked like. So Windows logs, application. And this was the exception. I'm going to put this up. So Let's scroll up. So if we would have bothered looking at the event viewer, we wouldn't be here at all because we didn't have to debug it all because we had the call stack, we had the exception and everything. But that's no fun. So let's not look at the event viewer and capture a dump on the crash and look at the faulting stack and all that stuff. Okay, so now we know everything we need to know about crashes. Let's move on to performance issues. Performance issues come in a couple of different forms, like the app is not responding, requests take too long. By the way, if a request takes too long, make sure you understand how long it should take, because otherwise you might end up optimizing forever. And then they might also come in the form of the CPU going haywire. And again, who did it? Well, there are two different types of hangs or performance issues. There's the low CPU and there's the high CPU. The low CPU is pretty evident that we're not doing anything. We're being as lazy as the debuggers that are going to debug this problem. So we're just waiting for someone else to do something or waiting on a deadlock. And high CPU issues, we'll look at busy threads doing a lot of computations or stuff like that, or more commonly doing a lot of garbage collection. And one way that you can get yourself into a high CPU and garbage collection situation is by creating a lot of large objects, because the garbage collector will do a full garbage collection every time you allocate a large object. And one way to allocate a lot of large objects, this is like tips and tricks if you want to have performance issues, it's to go ahead and concatenate strings in a loop. Because strings are immutable, so if you just add one character to a string, we'll have to create a totally new string. And if you look back to what we looked at, that is pretty evident because everything was stacked right after another, right? We saw the addresses, there was just like a tiny little bit of free space in between them. We couldn't necessarily expand the strings like ad infinitum, so yeah, don't concatenate strings in a loop. And when you troubleshoot it, you're going to go through 3 steps again. So it's going to be like the 3 miracle steps to troubleshoot anything. So determine if it's a high or a low CPU issue. More for yourself, because then you'll know what you're looking for. And then capture 1 or more dumps. It might be good to capture a couple of dumps to see sort of like, did this thread progress at all? Am I still waiting for the exact same thing that I was waiting for just a moment ago? Or did I go to something new? And then, in this case, look at all the stacks, because we don't necessarily have a single culprit that caused an exception that triggered a dump. We're going to just take a snapshot, like a picture that wasn't necessarily triggered. So, and by the way, if you can, go ahead and performance profile. So let's have a look at how this looks. Okay, let's get rid of him. And also my tweet deck. We're going to look at this ASP.NET MVC application. It doesn't necessarily matter what it is, but in this case, we have an issue. We have a situation where we have a page that is taking a little bit too long at times. So what I'm going to do is I'm going to go ahead and use a tool called Netling. Netling is just something I found on GitHub that will send just random, well, not random, they're going to send requests to the server one after another, essentially. So I'm going to go ahead and stress this using Netling by saying, go ahead and call up that page, use 8 threads, and go ahead and do that for 10 seconds. And we're going to see what happens. So I'll go ahead and remove the event viewer. It does not want to die. So let's go ahead and look at Task Manager instead. And go. Okay. So we are going to want to look at W3WP, which is the IIS process, and we're going to specifically want to look at this column, because this column is going to tell us how much CPU we're using. And let's run this, and we'll look, and is this a high CPU or a low CPU hang? Kind of low CPU. So let's go ahead and do that just one more time. And this time we're going to actually get a memory dump of the process. So we're going to do create dump file and wait. And there was the memory dump. Okay. So now we're getting ready to debug this. And I already prepared because I'm a good cook. So we have a memory dump of taken at the exact same place here. So what we wanted to do was we wanted to look at all the stacks. So we're going to run ~E. E is execute if you have an extension, and bang clr stack, which was dump out all the managed threads. And then we're going to use our matrix size to kind of look, okay, so what is happening here? Or we could just slow down and see that this thread, for example, is going to products, then calling into get all products in some data service, and then sitting in a wait. And if we scroll past this, by the way, if you're debugging a lot, you actually get good at looking at things while they're scrolling really fast. Because you also, did I mention lazy? Like you don't actually want to go through and look at all the threads. So all of them actually happen to sit in the exact same location. And then we would go in and look at the code and what was going on. Well, someone did something stupid, probably me trying to get this thing to hang. But it's now time to look at the code. So other ways we could do this is now go in, for example, with debug diag and choose, again, a crash hang analysis, because this time it's a hang. Remove the old data file and choose this one instead, and start the analysis. And this is now going to go through and do some, like it's going to look at all the stacks and look for common issues that it thinks could be causing a performance issue, like excessive weights, for example. And it's going to say, okay, so you have 8 threads waiting in a monitor wait. And this is kind of useful because it was 8 threads, and I could have looked through them, and I could have examined them and seen that it was the same thing. But this thing will do that for me. And again, I mentioned lazy. Yes. So this will help me out kind of figuring that out without having to do the work. And I'll go in and I look at this, and it's going to tell me, first off, that all of these are the same. Like it groups them together as being the same. And then it also shows me that this was the stack on that thread. So again, we're back to looking at the proper code. Let's go ahead and just for fun also do this in Visual Studio. So I'll close the old memory dump, and I'm going to go ahead and open up, open up a file. In this case, I'll actually pick the one that we just captured. And I'll debug with managed only again. But something went wrong. What went wrong? Any takers? No. Could have been a 32-bit process, but this is actually a 64-bit process because it was IIS. But what this is going to show me is the active thread. And we don't have an active thread here because we just captured the dump like as a snapshot. So we're going to have to use another feature in Visual Studio that's called debug windows parallel stacks. Have you guys seen this? Some? Okay. This is something that you can use while you step-by-step debug. And this will kind of give you that 10-foot view of all your threads and not just the one thread that you're normally on. And what this does is it kind of groups them together. In this case, we actually only have 8 threads doing the exact same thing because we're running 8 concurrent threads banging this products controller. But the fun thing here is that if we have the code, we can actually go in and click on it and get to the proper location. Again, right? For me at least, it's Jesus. So performance issues. Let's see. If it's high or low, we saw that it was a low CPU. Did it matter for this case? Maybe not, but at least we know we're looking for something that's waiting for something else, right? We capture the dump, we look at all the stacks. And then if you have another type of issue, you might want to go into profiling instead. Like if you have issues that you can't necessarily go through and stress to the point where you can get a memory dump while it's happening. So before I do this, I just need to shut down a few things because I'm keeping the symbols, and in that case this one works. So let's go ahead and do that one too. Let's go ahead and stop this debugger and see. Yes. Okay, so what we're going to do now is we're going to look at the same app. Actually, I did not write this app. I just wrote the problems with it. And one of the problems I kind of fixed in this one is if you look at the picture of the president, you'll notice that sometimes it kind of sticks. Like you have a situation where it goes through fine, and then from time to time it's stuck. And obviously I can't really reproduce this far enough to get a memory dump, so we'll have to do profiling for this. And I'm going to start off with George Washington again, so actually let me go ahead and shut that down altogether. So I'm going to go ahead and open up the project, and you could do this without having the project, but you would be limited in what you could see. So in fact, let me go ahead and do this so you can see. So what I'm going to do is I'm going to go ahead and go to debug, performance profiler, and I'm going to open that up. And in performance profiler, I can do a couple of things. I can either debug this and kind of start a process and profile it, or I could use something like an ASP.NET process that was already running, or another running app or whatnot. And then I have a couple of options for things that I can do, like look at the application timeline for exceptions and things like that, or CPU usage or memory usage. I'm going to go through the performance wizard, and I already know, because I know what the problem is, that this is going to be a low CPU situation. So we have two options when we go ahead and do profiling, and one of the options is CPU sampling. So CPU sampling, what it will do is it will go in at certain times, like every so often, and slice the stack and say who's on top, who's on top, who's on top, and it will record that and figure out that this function spent this much time, like this much CPU time. And then we have what we're going to use, so that's used for high CPU issues, but we're going to use something called instrumentation. And instrumentation will go in and put in markers at the call of a function and at the exit of a function. And it will record the proper elapsed time for that method. So that's what we want to look at. And I'm going to just do next, finish. And then it's going to start up the process, and I'll go through and clip my way through some issues. And I'm going to stop profiling. And then, as if by magic, it's then going to tell me exactly where my problems lie. So in this case, out of the total time I spent in the process, I actually spent 53.08% waiting for something, so in a task wait. And that was coming from a function called getColor which was in, I don't know if you how familiar you are with SAML, but this is a converter that converted the party nomination, Democratic, Republican, to a color so it would look pretty, because I do UX too, and so on. So here already, if we can go in and look at the code and point to that, we can see that most of our time was actually spent in this wait. This wait is, of course, fictional, but it could be waiting for a database, or it could be waiting for another process or an API or something. So profiling is awesome if you can reproduce it on your machine, and if it's a small enough thing that you don't want to grab a memory dump. Okay, let's see here. And then the last one we're going to look at are memory leaks. So a memory leak will also have a couple of ways that it can manifest itself. And one of them is out of memory exceptions. But you can also see things like slow response times, because suddenly the GC is just using up way too much time. Or you can see something that is pretty common that you see, for example, in Task Manager or in perfmon, that memory is just kind of growing, and we want to investigate what's happening there. So what I'm going to show you, well, let's go ahead and look at why this happens, because we have a memory manager. We kind of use .NET because it has a memory manager as a service, and because C# is awesome. But if we don't tell it to garbage collect, or rather if we tell it to not garbage collect, it won't garbage collect. And a couple of ways to tell something to not garbage collect is by adding things to cache or session state, or adding things to pinned or static object that will then hold on to things. Or by blocking the finalizer, there's a sure way to get a memory leak as well. And then we have some other memory leaks that are a little bit more subtle, like assembly leaks. So an assembly leak will happen for some constructs. For example, if you deserialize something, it might create a dynamic assembly, or, a number of regular expressions might create dynamic assemblies. And if you do that enough, and if you do that in bad ways, like using the wrong configurations and things, you'll end up with assembly leaks. In that case, you look at LM and see, ooh, I got so many assemblies that I don't recognize. Okay, so let's investigate that. Or you could go in and have a native leak. So if you use a COM component that you call, and that has done new and didn't delete anything, that would cause an issue too. If you have a memory dump, again, the magic 3-step process, we'll go ahead and capture multiple dumps. And the reason why we capture multiple dumps is we want to compare things. We want to compare how many objects do you have here, how many objects do you have there, because that's so much easier to compare and see what you're leaking, instead of having to figure out, is this odd? Should I have like 10,000 strings? Is that normal? But if you see that, if you can compare and actually find out what's leaking, that's a lot more usable. And then we saw earlier in Windbg that I would run, for example, gc root and figure out why things were still around. And for native leaks, you can use debug diag too. It has rules that you can set up, so it will put in markers when you do new, and when you do delete, and when you allocate a handle and things like that, so that you can figure out where did you go wrong, what did you mess up with. So let's go ahead and do the final investigation then with the memory leak. And I'll start off in Visual Studio, in Windbg. So we'll go directly to dump heap stat, because that will tell us all the different objects that are on the heap. And I'm going to do a little trick. Let's see, prefer DML 0. You don't have to worry about this, but this is to fix a performance bug in Windbg. I actually found myself debugging Windbg, which a weird thing. But then I figured out these blue lines, they're kind of neat because you can click them and they will do great things. They can also cause big performance issues if you want to enumerate a lot of different objects at the same time. So if you look at dump heap, then and troubleshoot a memory leak, what you would do then is you would go through the objects and say, is anything here looking kind of unusual? And this is where your trick with the multiple dumps come in, because then you have the chance to compare them. But I'm a seasoned pro, so I know that having, for example, 20,000 HTTP requests is very unusual unless you have 20,000 current requests coming in. So, because they should go away once they are served, they should just be removed. And you would look at things like, so there's a recurring number of 20,887. So the fact that I have so many HTTP requests and HTTP responses probably means that they are connected somehow. And if I get rid of the HTTP requests, I'll probably get rid of the HTTP responses too. And then I'll go through and I look at things like, I don't know, what else is there? There's some worker requests here. I have something else that, okay, so I have 20,000 news controllers. So that's an object that I created. That's the one that actually handles the /news request. And that looks weird too, but that kind of explains, so if I have that many controllers, that's why I have that many HTTP requests and such. So I'm going to go ahead and dump out all of them. And this is where the whole preferred DML0 comes in. So dump heap empty. Empty stands for method table. This was what we saw earlier, and this kind of is what defines the class. So dump heap, dump out anything that has that method table. And we wait. And we wait. And then we go in here because we're bored. So we'll go ahead and ask this one to do memory analysis at the same time. So let's go ahead and grab that same thing and start your analysis. So this is going to do now the same thing. It's going to enumerate all the objects, kind of figure out what it thinks I am leaking. This should be done in just a little bit. The bad thing about SOS is that you can't actually cancel a command in here, so you can sit here all day and do Control-C, and it won't happen. So let's say I thought this was going to be a little bit quicker, so I'm going to go ahead and actually start up. Let's see if it was finished. No, okay. So I'm going to start up the investigation also in Visual Studio at the same time. So in Visual Studio, I'll open up that same memory dump. And I had it at junk, demo dumps, okay. So this was the one that was leaking. And in this case, I'm not going to do debug with managed, not debug with mixed, but I'm going to do debug managed memory. And what that will do then is it will also go through and enumerate all of the objects. It will also go through and enumerate all the root, so it will kind of run GC root, if you will, in the background and kind of figure out why things are sticking around. So while that is running, let's go back to this one, because now it's done. And we can now pick any of them. In theory, we should pick all 20,000, but that's going to take a little longer than we have. So we're going to just pick one and say GC root to figure out why that is sticking around. And that now gives us a similar root stack that we saw with the string that we looked at earlier. The difference here is that this news controller item, it's stuck in something called a cache item removed callback. Eventually, if you look up here, it will be in proper cache. But at this point, we would then go ahead and Google for cache item removed callback, or talk to whoever did that news controller and figure out, do you know what this cache item removed callback is? And they would say, yeah, you know what? If I look in this code, what I'm doing is I'm going in and I'm caching a bunch of stuff with cache.add. And at the end, whenever the cache item is ready to be removed, I want to go ahead and call back this method to clean up some other stuff. So that's a cache item removed callback. Don't worry about like the details around cache item removed callback. This is just one example of how you can sort of lose memory. And then, okay, so why would that cause the news controller to stick around? Well, if you're sitting there in cache and say, call back this function when you're done, which is like in 5 minutes or whatever, then this object has to be around for you to be able to call a method on it, right? And that is why we're leaking this. If we would instead have a static callback function, we would not have this leak, we would not be here. You could go to a different session and not have to worry about memory leaks at all. So that is how you troubleshoot them. Let's go ahead and look at what debug said. I'm going to have to refresh this to get the blocked content to show up. Yes. Okay, so in debug, it does what we did, but it also does a few other things. It runs a couple of different commands that it thinks are kind of useful for you, like figuring out, how many objects are ready for finalization. That might be interesting to you. Also, might be interesting to figure out how much memory you actually have in .NET memory. We could get this from eheap-gc, but this does it automatically for you without having to remember to do that. Gives you a few examples of blog posts that you should look at that might have to do with this. A lot of them go to my blog, so if you ever want to go to my blog, you can just run debug and pick any link in there. And then what it will do is it will enumerate the heap, and then it will go in and say, these things look kind of strange, okay? So, for example, we know that we sometimes leak web UI objects, so we're going to mark those with red. We know that we sometimes leak system data objects. This is based on heuristic information from us debugging tons and tons and tons of memory dumps. And then purple is basically your own objects. And in here, it would kind of stick out and say, you might want to look at this news controller because you have like this many of them. So that's what you get from debug, but in Visual Studio, let's see what happened there. So in Visual Studio, we went ahead and loaded up the dump, and here I'm going to actually use the baseline dump. This was a memory dump I took at the beginning of the process before the leak happened. So now it's going to enumerate, and obviously it's much smaller, so nothing. Okay, ignore like this and have a look at this instead. Because as soon as I shut this down, like everything will go away. So if you have two memory dumps, what you'll get is the difference between them. And it will, for example, say, between these two, you have leaked, in this case, 20,000 HTTP responses. And it will actually give you down here, so let me go ahead and Windows plus this too. It will say, okay, most of these, let's go ahead and look at the news controllers instead. So most of these, in fact, 20,000 out of the 20,000 or so objects are rooted in a cache item removed callback. So this is essentially going through and doing GC root on all of those objects and giving us the proper stats instead of us having to go through and do that. So Visual Studio is doing some real magic when it comes to memory debugging, especially for memory leaks. This particular feature is something that you could use if you were F10 debugging too. So if you get to a point where you see, okay, so between, like, so I'm going to stop here on a breakpoint, then you can go in the diagnostic toolkit, take a snapshot, and then move on, take another snapshot, compare them, and get this view and figure out why something is sticking around. Okay, so we saw how we did that, and then I just want to end off. So now you have basically all the tools that you ever need to do these crime scene investigations. But I want to end off with a slide on just some resources that you might want to look at if you want to go further in debug. So debug diag, obviously, if you want to download that. If you want to look at these slides, I have them on slideshare.net. And if you want to try this for yourself, all the demos that you've seen today, you have them under debugging demos on my GitHub account. So with that, thank you very much. It's been awesome having you. And I don't think I have any proper time for questions, but if you want, you can come up. I'll be here.